Welcome to Study Loop.
So now we'll work on problem 66 from chapter 17. Now this question is asking us, or it's telling us that we have a 20 milliliter sample of 0.125 molar nitric acid being titrated with 0.150 molar NaOH. So it wants us to calculate the pH for 5 different points and then sketch the curve, and also to indicate the volume of equivalence. So let's go ahead and calculate our first point. And we can make our first point when no base has been added. Okay, so this is just based on the initial concentration of acid. So to get the pH, all we need to do is take the negative log of the concentration of nitric acid, which is 0.125. And this will be equal to pH, which will be equal to 0.903. So we can move on. We can do our third point. Let's skip ahead to our third point because I want to calculate the equivalence point now. And then we'll go back and calculate something between initial and the equivalence point. So at the equivalent point, so we can calculate the moles of acid that is present, and we get that by multiplying the concentration by the volume, and we get 0.0025 moles of acid. And so at the equivalence point, this should also equal the amount of base that we have. So to get the volume of base that we need to use to get this, we are going to divide this amount of moles, 0.0025, by the concentration of base, which is 0.150, and then this will be equal to 16.67. So 16.67 milliliters is this is actually a converted from liters to milliliters. And then our pH, since it's a strong base and strong acid, is going to be equal to 7. So since we've done we did the equivalence point, let's go back and add something roughly maybe halfway in between, about 8 milliliters. So when we've added 8 milliliters of base, we can get the concentration, the moles of base that we've added by multiplying the concentration times the volume. And if we do this multiplication, we'll get moles, and what we get is 0.0012. Now, to know the amount of acid that we have left, we need to subtract this from the initial amount of acid, which is 0.025 moles of acid minus 0.0012 moles of base. So this is almost the equivalence point, so that's why it's so close here. And we get 0.0013 moles of acid remaining. So if we do 0.013 moles divided by the liters, which we initially had 20 milliliters of acid, and we added 8 milliliters of base, so now we have 0.028 or 28 milliliters of total solution, which is equal to 0.046 molar. So if we take the negative log of this, we get pH is equal to 1.33. So points 4 and 5 we can do beyond the equivalence point. So to keep things simple, we can go 8 milliliters beyond the equivalence point. And so since we added 8 milliliters at the beginning, we had 0.0012 moles of base. So now, since we're past the equivalence point, exactly 8 milliliters past the equivalence point, we now have 0.0012 moles of excess base. So the question then is, what is our volume? Or what is the molarity? So if we do the moles, this is 1, 2. Let me go ahead and make this clear. Divided by the volume, which is 20 plus 24.67. So 44.67 or 0.04467. We get concentration, which is 0.027 molar. We calculate pOH by taking the negative log, which is 1.57. And then pH would be equal to 14 minus that, which is 12.43. So our last point that we'll calculate is we'll add 8 more milliliters, 32.67 milliliters. So we're now going to have 2 times this value. So we're going to have 0.0024. Because now instead of 8 milliliters excess, we have 16 milliliters of excess base. And we do the same process. We do moles divided by the volume, which should now be 0.05267 in liters. Which gives us this concentration, which gives a pOH equal to 1.34 and a pH of 12.66. So now what's left is to draw our plot. And I'll go ahead and open a new page to be able to try to do this as well as I can. So we're going to look at, on the x-axis, volume of added base. From our problems, we go up to about 32, so we'll put 16 in the middle. 24, 32, 8. And then on the left, we can put on the y-axis our pH units. Okay, so we can go ahead and plot our points. So our first point was 0 milliliters of base and 0.93, so about a third of the way. Let's go ahead and plot the points in red. That's not the point. Here's our point, roughly about there. So our next point is 8 milliliters of base added, slightly increasing about 1.33, so just slightly above and there. Our third point is 16.67, our equivalence point at pH of 7, so slightly above 16 at pH 7 right there. Then 24.67 and a pH of 12.43, somewhere around here. And then 12.66. So approximately. Now let's plot in blue. Now we know the shape. We might be able to be tempted to draw a more sloping line here, but we know the shape the general shape of a titration curve. So we're going to go more straight at the bottom and then dramatically increasing, dramatically increasing, and then sloping out. So this is our curve for this problem.